don't know if you can hear the siren, probably not. Doppler effect. Use algebra tiles to find the simplified algebraic expression for x plus 3 times x plus 2. Sketch your diagram below. On your mark, get set, go. So sketch a diagram, right? Now the reason is we may ask you to do this on a test, right? Although the emphasis will not be on algebra tiles, there is an expectation that you know algebra tiles. And that if I ask you to sketch this out, then I expect you to be able to do that, right? So go, do it. And I'm going to pause now. Okay, so your sketch. Now to do the sketch, I'm actually just going to pop into here. This is available for you if you want it, right? It's a Smart Notebook file, which is up in Schoology, and to get to it, you need to go to express.smarttech.com. And what that will do is allow you in your browser to open up a Smart Notebook file, and then you can manipulate, right? So we see we got an x and an x, and x times x is going to give me x squared, right? And we're actually even following the area model and putting that together with what we know about FOIL. We're really going to be working out 4 areas, right? And so one of them is, well, I can do x times x. And I can do x times 2, which is going to give me 2 x's here, right? X. And one down here. And actually, before I do much else, let's write this in. This length is x plus 3. And one thing I always do with binomials is put them in brackets. And this is x plus 2. And I do a little burst. That's the pull over. I'm right behind you, Siren. Okay, so now, we're doing 4 different areas, right? We've got x times x, we've got x times 2. We now go with this x times these 3, which is going to give me 3 x's, right? So they're going to fit in here. And this is what you'll have to sketch or interpret, right? So on the test, it'll either be draw us a sketch of this or interpret a diagram that's given to you. And the last thing we have to multiply is the units, which is the 2 times 3. And I'm just going to fill that in, right? And I actually don't even have to know what the answer is. I'm just going to fill it in. Like so. Okay, and from this, we can read the area, right? Now this is a simplified form. It's the entire area, right? So this area is x squared plus 1, 2, 3, 4, 5 x's and plus 6. Okay, so the area model gives us a simplified expression for the area, right? And now we go back here, and we've done this. So determine the simplified algebraic expression without using algebra tiles. We're now going to use FOIL. So we write x plus 3, x plus 3 times x plus 2. So FOIL is first, x squared, outer, plus 2x, inner, plus 3x, and last, plus 6. And then you collect like terms, and we get x squared plus 5x plus 6. Any questions? All right, ready to move along. Substitute x equals 4 into the factored form and evaluate. This is factored form. Okay, so factored form will have a set of brackets, at least one set of brackets. Substitute x equals 4. So we go 4 plus 3 and 4 plus 2. (42). Substitute x equals 4 into the simplified form and evaluate. So our simplified form is x squared plus 5x plus 6. Are your answers from C and D the same? Yes, there are. Gentlemen, the mic will pick up everything you're saying, just so you know. Okay? Any number for x when substituted into any form of the polynomial, right? So we're saying the factored form and the simplified form are identical. And if that is true, then any value of x we substitute in will evaluate to the same value, right? So you're going to get 42 out of this. Any questions? We good? Ready to move on? Do you need a moment? I'm going to give you a moment. Is the polynomial 3x minus 2 times x plus 5 minus x minus 2 in factored form? No, it's not in factored form. Why not? Factored form would simply be written as something times something, or something times something times something times something, right? The only thing you can have in a factored form is the operation to multiply, right? So it's like if I factor 36, I can write it as 2 times 18. I don't write it as 2 times bracket, 40 minus 12 or something like that, right? Which would be totally wrong anyways, but factored form requires it to be only written as a product, okay? So no, factored form So how are we going to write this in simplified form? What does simplified form look like? That's factored form. Yeah, just values, right? Yeah. So it's going to look like ax squared plus bx plus c. So remember, this is simplified form, right? In that form. So how are we going to do it? We're going to have to expand it, right? Okay, so watch, because this is very, very, very important. Okay, so what I really have is a binomial times a binomial, and then I'm squaring a binomial, which basically means I have another binomial times a binomial. Now, if there were a plus sign there wouldn't be too much to worry about, right? We could just go blithely firing away, but there's a minus sign there, so we have to be really careful when that happens. So what I'm going to do is I'm just going to rewrite it like this. And I'm going to put brackets around that first expression to say, hey, let's separate that out because we have to do this first. And then I'm going to do the same thing here. So now what I've done is I've written the second expression, the x minus 2 squared, as x minus 2 times x minus 2. And I do that. Now, when you come to realize that, hey, I can multiply binomials a little faster if I just do this, then that's fine, right? Now, all I really care about is your final answer to this, right? But I want you to get your final answer. So first step, I just want you to expand these two. So I want you to now write this, where inside these brackets will just simply be the expanded form, and maybe you go one step further. And then you simplify what you wrote. So when I multiply two binomials, how many products will I always get? 4, right? That's where FOIL comes from. First, outer, inner, last. Okay, so I'm going to pause. Okay, I'm going to go directly to this line here, he says, and when you don't actually point at it, right, so say, I'm going to this line here. That now people can see in the video. But you may do this line here, which is the 4. So this is how I multiply binomials, right? I know the first term only comes from 3x times x, so that's going to be 3x squared. I know that the middle term is a combination of the outer, which is 15x minus 2x, so that becomes plus 13x, and the last term is minus 10. Now, the FOIL would be this, right? You get 3x squared plus 15x minus 2x minus 10, which you then collect down. You're collecting your middle terms now. If you want to go from here right to here, that's fine, okay? I don't need to see this middle section. Same thing happens over here. There's actually a little trick with this. This is squaring a binomial. When you do that, here's the trick. And you don't need to use it, right? You can always FOIL and do this, right? So whatever you're comfortable with, but the trick is this. It's this squared, x squared. It's this times this, which is minus 2x, doubled, so that's minus 4x. And then it's this squared, which is plus 4. Okay, that's the trick in squaring. Now what happens? You're FOILing, so you get x squared minus 2x plus 4, and there's your result. Okay, so if you need to FOIL things out, there is absolutely nothing wrong with that. You're always going to get the right answer if you do FOIL. If you start to realize that, hey, I'm getting good at this multiplying stuff, I can collect these two terms in my head, then I don't need to write them down. The only important thing is make sure you get it right. Okay, if you get it wrong, then life is not good. Okay, are we done? No, we're not done. So now we're going to remove the brackets, and here's the important thing. This is going to come up a lot. Nothing happens here, right? It's just 3x squared, although I should throw some equal signs in, right? So it's 3x squared plus 13x minus 10. What happens here? Here. What happens there? What do I do to each of the terms? I change their signs. If I flip them, I'll end with 1 over. I don't want to flip them. Okay, so I'm going to change all these. So it's minus x squared plus 4x minus 4. We are distributing this negative through the brackets. If there were a number in front, like a 2 there, we would be multiplying everything by negative 2. So that's why when I did this originally, I split this up here. I wrote it down as 2 sets of brackets with the minus sign because I got to say, hey, in the end, once I've multiplied the binomials, because order of operations says multiplication comes first, once I've multiplied the binomials, then I'm going to do this subtraction operation, and I have to remember I've got to change all of these signs. Okay, and then we collect. So we get 2x squared plus 17x minus 14, and that is simplified form, right? Factored form would be 2 sets of brackets. Now, as to whether or not that factors, I have no idea. That's right, is that factored? I don't know if it does, but they didn't ask us to do it, right? So we don't have to. As a matter of fact, we're not even doing factoring, we're not even doing factoring, we're just doing multiplying, so why do you care if it factors? That's another lesson. Substitute x equals 1 into the original expression. Oh my god, I don't know what the original expression is. Hang on. So the original expression was 3x. Okay, let's rewrite the original expression. Rewriting the original expression is really like doing formula, right? Remember in math, we do a lot of formula substitution answer. So if I rewrite the original expression, okay, and then I'm going to substitute into it. Okay, and then I'm going to evaluate. So 3 minus 2 is 1. Times 6 minus negative 1 squared is 1. I guess I could write an equal sign there. Okay, so I get 5. Now, substitute x equals 1 into the simplified form, which is down here, so I gotta look. 2x squared plus 17x minus 14. 2x squared plus 17x minus 14. And they're the same, so what does that make you think? Maybe they're equivalent? Do you think? Is that a guarantee that they are equivalent? No, Mr. Yanover, it's not. Really? Yeah, I don't. Right? You may have fluked into a value where it just happens to evaluate, so we don't use that as a guarantee, but we can use that as a positive sign. Hey, it worked, right? So, okay, I think that maybe this probably is. So are your answers from C and D the same? Yes, they are. Since we can only use the acronym FOIL for the product of 2 binomials, we will now learn how to use the distributive law to multiply polynomials with more terms. Expand and simplify each of the following. This is not going to be a major part, okay? You will be multiplying binomials for the next 3 years, a lot, okay? So you really want to be good at multiplying binomials. You're going to do this a little. You need the skills to do this, right? And you're going to have to practice this, right? It's all about practice, right? You play sports, it's all about practice, right? You're going to practice, practice, practice. You know, this looks easy, right? So you guys have been sitting back just sort of watching videos and not doing any work. It's not going to work in the long run, right? Because it all looks easy there, and then all of a sudden it's in front of you and it's not so easy anymore. So you got to do some practice. Okay, distributive law basically says we're going to take the 2x and we are going to distribute it through the brackets, and then we are going to do the same thing with the -3. So I would like you to do that. Okay, so two terms, the 2x times x squared, right? This is the expansion. You got 2x cubed minus 8x squared minus 10x minus 3x squared plus 12x plus 15. So watch the signs, make sure your signs are correct. Make sure that you have 6 products, and now you collect like terms. So I have a 2x cubed. Okay, and I'm going to check them off as I go along, right? Because there's a lot of terms. So I got minus 8x squared minus 3x squared. I don't see any other x squared terms, so that's minus 11x squared. Got minus 10x plus 12x is plus 2x. And I've taken care of everything but this, and that's plus 15. So binomial times trinomial yielded a polynomial in 4 terms, the special name for which is a polynomial in 4 terms, right? We don't have special names above trinomials. What's going to happen when I multiply a trinomial times a trinomial? How many products will I get? Anyone? 9. Okay, we're going to have 9, right? So we have to distribute the x through here. And then we distribute the y. And then we distribute the 3. Right? And if you look up there, there's 9 arrows, and now it's covered everything over, so I'm just going to clean it up. Okay, so I get 2x squared plus 2xy plus x. Now I'm going to go with the y, so I'm going to get 2yx. Hint, always write your variables in alphabetical order, okay? Because it'll help when it becomes, so I've got y times 2x here. I'm going to say that's plus 2xy. I've got y times y, that's plus y squared. And I've got y times 1, which is plus y. And now I'm going to go through and do the 3. So you notice right now I have 6 products. We need 3 more. So I'm going to go through and multiply by the 3. So we'll get a plus 6x. And we'll get a plus 3y. And we'll get a plus 3. Are there any like terms? Well, I see only 1x squared. I see 1y squared. I see an x, I see a y, I see a 3. But I do see 2 terms that are like terms, which are these guys. Oh, wait, and I've got an x. And I've got y's. Okay, so we have a number of like terms that need to be collected together, right? If I made a mistake, just let me know. Okay, so I'm going to start with the 2x squared. I'm going to go to the x term, I guess. Well, let's do the xy term. So, what?
The first 2xy, isn't that just xy?
You're right. Good catch. So let's call that 3xy. Now, really important, in Math 31, where stuff goes on for like 3 boards, and you notice an error on the first board, please point it out then. Don't wait. Because otherwise we'll be like 3 boards down the road, and it's like, hey, that thing there, second line, that should be like 3xy. Oh, great, let's redo this now. There's 20 minutes worth of work.
Do you do y squared?
Well, you know what? I'm gonna save the y squared for the end. You know, but I'm not gonna mark you wrong on whatever order you give. Okay, I'm gonna look for, I think there's gonna be about 5 terms. I'm gonna look for the 5 terms. All right, so I got the xy term. Let's do the x's now. So I got plus 7x. Then let's do the y's, and I got plus 4y. And then let's do the y squared and the constant. Yeah, I don't know. Like, yeah. What do we got? 1, 2, 3, 4, 5, 6 different kinds of terms, right? We have x squareds, y squareds, x's, y's, xy's, and numbers. You could do this, no, I don't know. Yeah, I guess you could do this with algebra tiles, right? Yeah. You wouldn't want to, I don't think. Right? I mean, at some point it just becomes a little too, you know, there's like too much there. So this is just a shortcut. Okay, I leave you to do the next one. How many products are you going to get before you collect? 6. Okay, so do it. I shall pause. And 1. Okay. Biggest thing to watch out for is 2 things. Number 1, you're going to get 6 products. Number 2, watch out for the signs. So I get negative 3x squared. I get plus 4xy. I get minus 3x squared y. Okay, at this point we're keeping terms in alphabetical order, right? So that way it's easy to recognize like terms. I get plus 4y squared. I get plus 3x squared minus 4y. Okay, is that right so far? That's why I have you guys go ahead, right? Then we can check. Okay, so I get negative 3x squared. No, I don't. I get these 2 guys, the x squared terms cancel each other out, right? We get negative 3x squared plus 3x squared, so that's gone. Let's go with the negative 3x squared y plus 4xy. Do you see any other x's? Okay. I've got this. And so what I'm doing is, as I'm checking them off, I'm kind of scanning for like terms, right? Okay, I got a 3x squared y. Okay, I got a 4xy. Let's go with that. I've got a 4y squared. I got a minus 4y plus 4y squared. Okay? So I think that's it. Now, and the thing is, we can't come up with any rule of, hey, when you multiply a binomial times a trinomial, you're going to get 4 terms, right? It depends on the variables. Yes?
Okay, I was looking at my sheet when we were checking that. Isn't the first one negative 3x cubed, or is it still negative 3x? It's negative x times 3x squared.
You're supposed to be checking. Why don't you guys check?
So it's still going to be negative.
Yeah, I'm just going to have to re-record this last period of the day then. Making all these mistakes.
That's just a reversal.
Yeah, exactly. No, it's not. It's going up. I don't care. Okay. We're multiplying 3 binomials together. So here's how you do it. You do it 2 at a time. So the first thing we're going to do, this is the order I do. It doesn't really matter, but I'm going to multiply these 2 first. So what I'm going to do is write down, it's 2p minus 1, and then I'm going to multiply these guys together. And this works out to 3p squared. Minus 12p plus 2p is minus 10p minus 8. What you're aiming for eventually is to be able to just write down the product of 2 binomials without going through and writing 4 terms, right? So you just get used to doing the collecting of the outer and the inner in your head. Okay, and now we have binomial times trinomial. Since it's only in one variable, it's going to collect down into like 4 terms, right? Okay, let's see if I can do this right. 6p cubed minus 20p squared minus 16p.
Isn't it 12?
No, we're multiplying.
No, but on the top line, 3 times 4 is 12.
Yep. Minus 12 plus 2 is minus 10. We're doing big kid math now. We're combining outer and inner. That's outer and inner. Okay, I've graduated. I'm out of junior high now, so I don't need. That's how I do it, right? Is I just say minus 12p plus 2p is minus 10p. Okay, so but it's okay to write out the 4 and then collect it down into 3, right? Minus 16p minus 3p squared plus 10p plus 8. Okay, look, you got to do what works for you. Okay, so if you can, you know, square that and just say I'm going to collect outer and inner in my head, and you're doing it consistently right, time after time after time, then do it that way. If you are not doing it consistently right, time after time after time, then do not do it that way. Right? Write out the 4 products and then collect them. This is something you have to work out for yourself. So 6p cubed minus 23p squared minus 6p plus 8. Okay, Megan, did I get it right?
Yeah.
Okay. You're supposed to say, I don't know, but it's the same thing I got.
Yeah.
Okay. So why are there only 4 terms?
Are we supposed to return the 4 terms every time?
Okay. Why are there at most 4 terms? Because, you know, we did another one and there were like 5 terms. Like, shouldn't this have, you know, we do binomial times binomial, we know usually gives us 3 terms, then we multiply that, we got 6 terms. Why does it collect into 4 terms? Yeah?
Because we're at 4 different types of
Yeah. It's the powers of p, right? So when we're in a single variable, right, this would not work if there were like x's and y's in there, because then you get x, y terms in this. All we're going to get in this product is powers of p. And the highest power of p is p cubed. So that's why we can have at most 4 terms. We can have a p cubed term, a p squared, a p, and a constant. So that's why there's at most 4 terms, right? Because you can't go any higher than that. Now, if there's x's and y's, then, all right, all bets are off. It's just all over the place. That's okay. Okay? Not even, I'll stay for it, don't worry. Give me 1 second. Simplify and then verify, okay? So again, one way. If we simplify, we should get an expression which is equivalent to. Is this factored form? No, right? Because it's got a minus in there, so it's not a factored form. Yeah, just grab one of each. Holy smokes, there's A's and B's and everything's. Okay, 6a squared minus 4a plus 9ab minus 6b minus 3a plus 2 minus. Okay, now big thing here is when you write that minus, you put down a set of brackets and we're going to now square a plus b. And we could do this up here. And you get a squared plus 2ab plus b squared. Okay? So that's what the a plus b quantity squared works out to. A squared plus 2ab plus b squared. Really, a really important thing here is, since it's being subtracted, this needs to be in brackets. Okay, so now we'll go through. We can collect a few of these terms, I think. So let's do that. So let's say we got 6a squared. I've got minus 7a plus 9ab. Okay, so let's just make sure I've minus 6b plus 2 minus a squared minus 2ab minus b squared. Okay, so when we're subtracting the result of that last multiplication, that's why this has to be kept. So really, you know what, let's do this. We'll just bracket this as well, and we'll just say, you know what? Let's keep things in brackets. We'll do our products, right? Because the last operation we do here is this minus. Well done. Must be so rhetorical. It's done. Okay, so we collect, we get 5a squared. Okay, let's check this off. Got my a squareds dealt with. Let's do the ab's. So we got plus 9 minus 2. So it'll be plus 7ab I've got an a term here, minus 7a. That's it, minus 7a. I got a b term, minus 6b. I got a minus b squared and a plus 2. Wow, okay, so what, I'm not even going to ask if it's right, because if it's wrong, the verification should point out to me that I made it. So if I made a mistake, don't tell me. Let me find it for myself. And that's the whole point of the verify, right? Is, hey, if we substitute values in, then we know that this and this should give me the same thing. So here's what we're going to do. We're going to substitute into here. So I'm just going back and writing the original. Okay, and I'm going to substitute in. So I'm not going to say it equals 2, but I'm going to say it leads to. Okay, so I want a equals 2. And b equals 1. Yes, Alex.
I have to look for CT.
Okay. And a is 2, b is 1, and that's squared. Can I get this microphone?